I'll show you some examples of how to use vector in Sway. In Sway, there are two types of vectors, storage and heap. Storage means that it is a state variable, so this will be saved onto the blockchain. Heap means that the vector will be initialized inside memory. So a vector that is initialized inside a heap will only exist while the function is executing. Storage vector is like an array declared inside a state variable in Solidity, and heap vector is like an array that is declared inside memory. Let's start with storage vector. First, I'll need to import the storage vector by typing use std storage vec. And then inside the storage, we'll declare a vector. Let's create a vector of nums, so say nums, and this will be storage vec of type u64. And we'll need to initialize this, so say storage vec curly braces. Okay, let's move on. Here are the topics that I'll cover for storage vectors. Let's start with push. Push will append a new element to the end of the vector. So say storage, the vector is nums dot push. Again, nums is a vector of type u64, so we'll push some number, let's say 100. Okay, let's push several more. In total, we'll push 6 elements. Okay, next let's talk about pop. What pop will do is it will remove the last element, and if there's no last element to remove, then it will return a none. Hence, it will return the option of num. If there is an element that was removed, it will return sum with the number. If the vector is empty, then there is no element that was removed, so it will return none. For our example, we pushed 6 elements, so if we call pop, we will get 600 back. So let's say that last is equal to storage.nums.pop. This will remove the last element, and at this point, the last element will contain 600. So last will contain sum, it's an option type, and inside this sum, it will have the number 600. How do we get an element from the storage vector? Let's try getting the first element. So say that first is equal to storage.nums.get. We want the first element, so we'll access the 0th index. Similar to pop, the function get will return the option, and then inside option, it will be the number. If the index is less than the length of the storage vector, then it will return sum with some value inside. However, if the index is out of bounds, then calling get will return none. So for example, calling get 0, we know that the 0th element contains 100, so this code will return sum 100. How about if we call storage.nums.get 1000? Well, we know that the length of the array at this point, we did a pop over here, so it will contain these 5 elements. So trying to get an element at the 1000th index will return a none. So this will be none. Let none equals. Okay, let's move on. We can also update an element at an index by calling storage.nums.set. Let's update the 0th index, so say 0, and let's update this to 123, 123. There are 2 ways to remove an element from a vector, remove and swap remove. Remove will remove an element at the index, and then it will also return the value that was removed. Now, when we call this function, all the elements to the right of the element that was removed will be shifted over to the left by 1. For example, let's say that we have an array of 100, 200, 300, and 400, and we're going to be removing 200. After calling remove, it will remove the 200, and it will shift these elements, 300 and 400, over to the left, so our final vector will be 100, 300, and 400. On the other hand, swap remove will remove the element by replacing the element to remove with the last element, and then popping off the last element. So, for example, let's say that we have a vector of 100, 300, 400, and 500, and we're going to be removing 300. When we do this, it's going to first replace the element to be removed with the last element. So over here will come 500, and then it will remove the last element. It will remove 500. So the resulting vector will be 100, 500, and then 400. Okay, let's take a look at both of these functions. Let's start with remove. To remove an element, let's say let remove val is equal to storage.nums.remove, and let's remove the element at the first index, 1. Okay, to perform a swap remove, we'll type storage.nums.swap remove. Again, let's swap remove the first element. So inside here, we'll put in a 1. So these are 2 types of remove available in Sway. Let's take a look at how to get the length of the vector. So say that length equals storage.nums.length. Okay, we can also reset the vector. The only thing that it does is set the length to 0. We can clear out the vector by calling storage.nums.clear. Next, let me show you an example of looping through a vector. Now recall again that in Sway there is no for loop, so you'll have to use the while loop. Let's initialize a counter, let mut I equals 0. And to run a loop, we'll type while I is less than length. This variable length will contain the length of the storage vector, which we initialized over here. On each iteration, we'll increment I by 1, so say I plus equals 1. And inside the loop, for example, we can get the value of the element, so say let val equals storage.nums.get the element at index I. Now this will return an option, so to get the actual value, we can call .onWrap. So these are examples of how to use storage vector. Next, let's take a look at how to use vector and heap. The way you will use these methods, push, pop, remove, get, set, and length, are the same as storage vector. So I'll just tell you how to initialize a heap vector. And this is done by calling the function new. For example, let's initialize a vector in heap. So this means that we're initializing a vector inside memory. And this vector will only last while the function is being executed. After the function is done executing, this vector will no longer exist. Say that mut, we'll call this b, is of type vector, of type u64, and this will be equal to vec : new. And this is how you will initialize a vector in heap. And the rest of the operation are the same as I discussed in the example for the storage vector. Okay, let's try compiling this contract. Inside my terminal, I'll type fork build. Okay, and I see an error over here on line 41. So I'll go to line 41, missing the semicolon here. Okay, let's try compiling again. And our contract compiled.